Okay, here we go. Unit 4 review. Let's do it. Oh, move you up, move you back. So many things. Up, back, all around. Okay. So number 1, you have the absolute value of 5x plus 8 equals 12. There it is. Boom. So you're solving for x. Yes. So whatever is inside the absolute value, and there's nothing else, there's nothing on the outsides, so we're just going to set it equal to positive and negative. Go over here. 5x plus 8 equals positive 12. 5x plus 8 equals negative 12. Positive and negative. Then just solve both equations for x. I'll just do this one first. So, subtract 8 from both sides. 5x equals 4. Then divide by 5. X equals 4 fifths. Okay, so that's one answer. That's one. The other one, subtract 8. 5x equals 4. Oh, no. I was like, those are going to be the same. My bad. Negative 12 minus 8, Miss Bailey, is negative 20. Yes. Yes, it is. Divide by 5. Boom, 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 boom. So then, x equals negative 4. So those are your two answers. I'm going to write these down as I go. That way I don't have to do them over and over again. 4 fifths and okay. Oh, I could have paused you. All right, number 2. You're still solving for x. So now we have things on the wait, are they supposed to? No, I was not very creative. Okay. Now you're solving for x, but I have things, or you're solving for d. Now I have things on the outside. So you have to do PEMDAS backwards, basically. You're working from the outside in. So my first step is going to be to add 2. (16 plus 2, 18). Right? 2 times the absolute value of d plus 5. So now what are you going to do? I'm trying to solve for d. Divide by 2. Divide by 2. So you have the absolute value of d plus 5 equals 9. So now you don't have anything else left on the outsides. So you're going to put what's inside the absolute value equal to positive and negative. We'll go here. So d plus 5 equals 9. And I didn't really leave room. I guess we'll do here. D plus 5 equals negative 9. Positive and negative 9. And then go ahead and solve for d. So d is equal to 4. That's one answer. Negative 9 minus 5. Negative 14. So that's your other answer. So those are your two answers. 4 and negative 14. All right, so number 3, you have a graph like this. And write the piecewise functions for the given graphs. So let me label some of this. Sorry, this is negative 1, this is negative 4, negative 5, positive 5, 5. Okay. So I guess I can do that, whatever. So this one, let's find the slope of this graph. So it's probably easier to see on yours, on the homework. So you have the little grids. But it is going over 1, down, over 1, down 1, over 1, down 1. Well, I guess I should be going this way. Up 1, over 1, up 1, over 1, okay? So it's a positive slope. So your slope is 1 over 1, which is just 1. Okay, so your slope is just 1. And then your y-intercept, it gives it to you, doesn't it? Unless I drew it wrong. No, it does. It gives it to you. So your y-intercept is 1. Right? So knowing that, you can write your piecewise for the first section for this first one. Where am I going to do it? I guess over here. So I didn't call it anything. I'll just call it f of x. And I have 2 sections, so I'm going to have 2 separate ones. Ooh, that got away from me a little bit. So the first one, your equation is, your slope is 1, so that's 1x, and it crosses the y-axis at 1. One second. Okay, sorry about that. So 1x, you don't have to write the 1. So your first equation is just x plus 1. We can go ahead, we'll go ahead and write the domain for that, and then we'll do our second one. So our domain for the first guy, let me move you a little bit without knocking over my very cold coffee now. There. That is from, there are no arrows on this graph, okay? So we're not going to have any infinity or whatever in our domain. So this graph starts at x equals -4. So x is greater than or equal to -4. And then we're looking at the x value, so we're looking this way. And it goes all the way to x equals 1. So from -4 to x equals 1. We talked about this in class. You have a hole here. That means you have to write the equals to 1 here. X is equal to 1 here, and x is approaching 1 here. So you have to write the equals to on this equation, because this is a hole. So it's not actually equal to 1 there, it's just approaching it. Remember, we don't want to fall in the hole. We just get really, really close. So that's our first one. Our second section, let's find the slope of this little guy. So, let me make sure so you can use this point to find the slope. So your slope is, well, actually I guess you don't have to. You go down 2 over 1. Did I draw that right? I drew this wrong. Hold on. I think it's because the slope should be 1/2. 1 second. 1 second. -1, 3, -3. Oh, that's right. You go. Oh no, there's a point right here. My bad. My bad. There's a point there. Okay. So you do. You go down 1 over 1. Down 1 over 1. Oh, okay. Well, that's boring. I don't know what problem I was thinking of. So you go down 1 over 1. Down 1 over 1. Down 1 over 1. So your slope is -1 over 1, which is just -1. And then you could, looking at your homework, looking at the graph on your homework that's more accurate than mine, you could extend that line to realize that it's going to intersect the y-axis at 0. Or you can write using point-slope form. So our slope is -1. And then you can choose a point on this line. So 3, -3, x minus 3 minus. So that's writing in point slope form, which is y equals the slope which is like that. So that's your slope, and then my point that I chose is 3, -3. So -3, and then plus y1, so -3 again. But see, if you simplify this, you could leave it like that. That'd be fine. But -1, so that would be -x plus 3 minus 3. I distributed my -1, so y equals -x. Right. So this one is -x. So y equals -x. Because it's going to cross your y-axis at 0. But like I said, if you leave it in point slope form, that's okay. So then that one is true for x is greater than 1. There's a hole there, so it's not equal to 1. And then it goes to 3. So those would be your piecewise functions. Okay? All right. Oh, also on this problem. Let me erase some of this shenanigan. You have to find f of -3. That means when x equals -3, what is y? So when x equals -3, -1, -2, -3, y is it -2? It's hard to tell from my graph. Yes. When x is -3, y is -2. -3, -2. Okay, so you're just looking at the graph. And then the other one, f of 1. So when x equals 1, what is y? When x equals 1, what is y? So you're looking at your graph. You could also use your piecewise. But I think looking at the graph is easier. So when x equals 1, x is 1 here, this is 1. So y is 2. It is not -1 because this is not, x is not equal to 1 here. X is approaching 1 because there's a hole. There's a hole, there's a hole, there's a hole. So it's only equal to 2. So those would be your answers for, oh, that was B, for A and B. Okay, so number 4, once again, you have to write the piecewise function. This time, I have three sections. Come this way a little bit. Just a little, there. I have this parabola, so I have 1, 2, 3 sections. So, go ahead and look at your parabola. They kind of made it annoying because I labeled mine like they did. They labeled it 2, so they're counting by 2s. So this is actually 1, 1. All right, so this is a normal parabola. This is, the vertex is at 0, and you go up 1 over 1, up 1 over 1. So that is a normal x squared parabola. Okay, so we can go ahead and write that for our first one. Our first section is x squared. Let's go ahead and do the domain while we're here. So it doesn't have another dot, so just assume, you have to assume that there's an arrow going off in this direction, since there's no dot. Okay, so on the test it'll be more clear. So it is a parabola when, and then when does it switch? So all over here it's parabola, 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 when x is over there. Then when x gets to here, it's equal to 1, but then after that it switches. So you're going to have x is less than or equal to 1. x is less than or equal to 1. If you want to write, give myself a little bit more room here. Okay, if you want to write that it's greater than negative infinity, you can. But, I mean, you don't have to. Because it means the same thing. X is less than or equal to 1. So that already includes, that means it's going all the way to negative infinity. So you don't need to write that part in. If you do, though, I won't mark it wrong. So x is less than or equal to 1. Your second part, oh wait, before we move on, it has to be equal to 1 here because this is a filled in point, this is a hole. So it's equal to 1 here, not here. All right. So your second part, this is 1, 2, 3, this is 4. Is the line y equals 4. The slope is 0, it's just the line y equals 4. So 4. And then the domain of that guy, x is greater than 1, and then that goes until it goes from 1 to 2. Okay. Less than or equal to 2. Once again, it has to be equal to 2 here. It has to be equal here because there's a hole here. So this one is not equal to 2. So our last one, let me look at your more accurate graph. Oh. So once again, your slope is just, it goes up 1 over 1, up 1 over 1. So your slope is just 1 over 1, which is just x. So this is the line y equals x, which means it's going to cross the y-axis at 0, 0. If y is equal to x, when x is 0, y is also going to be 0. So this line would continue, and it would intersect there. So it's just y equals x. If you write an endpoint slope form, that's fine. And then the domain of this guy is x is greater than 2. And that's it. X is greater than 2 because, wait, yeah, there's no dot, which means we have to assume it goes on forever. If you mark it, because it's kind of hard to tell, as less than or equal to 4, so that's where the line stops, that's fine. There's no arrow, so it's not super clear what they want. So the one on the test would be more clear than that. Would be clearer, more clear. I don't know. I don't teach English. All right, so that is number 4. Number 5, identify the vertex and write the following as piecewise functions. Okay, so we talked about in class how the normal absolute value graph is y equals the absolute value of x. So if there's anything different, then transformations have happened, and your vertex is no longer at 0, 0. So this one, your vertex is 0, 0. Okay. So here we go. If it is inside with the 8, that means we're moving either left or right. So just like with the parabola, it's the opposite of what you see. So it's a positive 8, which means we move to the left 8. So our new vertex, negative 8, and then that's the only difference between this and this is the 8. Other than that, they're the same. So we don't move up or down at all. So that's your new vertex. So then your piecewise, you have one of them is going to be negative, the opposite, and one of them is going to be the opposite, the other one's going to just be what's inside. And, okay. Then why your vertex is important. Your vertex, remember, is the turnaround point. So my vertex is at negative 8, 0, so like right here. Okay, my vertex is there. So my slope is negative, and then I hit the vertex and my slope becomes positive. So that's why your vertex is so important on your for absolute value. It is your turnaround point. So the domain for the negative slope is when x is less than -8. Same number. And then it becomes positive after it hits the vertex. Right, so greater than -8. And then you can choose which one you want it to be equal to. I'll do the top one. So notice how these are all the same number. Your vertex is your turnaround point. So that was number 5. Okie dokie. All right, get your energy back up. Math, 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 math. Okay. So we are, sorry, that was mostly for me. So we're finding the vertex and writing the following as a piecewise equation. Okay, so the vertex, once again, you're comparing to this normal graph. So what's different? What is different? Play spot the difference. Well, I have this -3 and I have this 2. Those are my differences. Okay, if it's inside with the x, that means it's moving left or right. So x -3 means we move to the right. It's the opposite. So we move to the right 3 and up 2. Okay, so we move to the right 3 and up 2. So your new vertex is +3 and 2. That is your new vertex. Here, let me graph it. I like graphing these because they're easy. So 3, 1, 2, 3, and like 2. So there's my new vertex. Okay. This is 3, 2. Okay. So then write it piecewise. Let's see that. So I have a negative slope. If you ever have a number in front, that'll change your slope. We haven't had that. Maybe we had that once. Okay, but our slope is staying the same. So this just becomes negative x -3 plus 2. I have to erase my graph. Okay. And that is true from when x is less than 3. X is less than 3. Your other one, just rewrite it exactly as you see it. So x -3 plus 2. Okay, good. And then greater than 3. And then pick which one you want it to be equal to. I always do the top one. I don't know, it's a habit. Okay, you can leave it right here, that's totally fine. If you like reducing equations, go for it. So really, this could turn into, so if you're happy here, I'll leave it here. If you want to reduce, let's check your work on reducing. Okay. Okay. So this becomes negative x. Oh, this is not going to be enough room. Okay, we'll just rewrite it. Negative x -3 plus 2. All right. So this becomes negative x plus 3. I distribute my negative, and then plus 2. So you could also write this equation as negative x plus 5. Either one works. I will take either and be very happy with either one. Just make sure you keep the same domain. Your domain stays the same. If you reduce the bottom one, x -3 plus 2, then you get -3 plus 2, so x -1. So you can leave them like this. This is in point slope form. This is in slope intercept form. So either one is fine. It doesn't matter. Make sure you have the right domains though. So number 8. So 8 through 11, you're finding the inverses. So here we go. First step is to write it as a y equals. So y equals 4x plus 12. Step 1. That was step 1. Step 2. Step 2. Switch your variables. Swap them. Swap them out. So x equals 4y plus 12. And now you're just solving for y. I'm going to subtract 12. So I get x minus 12 equals 4y. Okay, I'm solving for y. So I'm going to divide by 4. Divide by 4. Divide by 4. If you leave it there, not the end of the world, but you could reduce this. Okay? So x over 4, that is, I'm going to draw on my invisible one, that is 1/4 x, 1 over 4 times x, and then negative 12 divided by 4 is negative 3. So that would be, oh, I didn't write the little, so that would be your inverse. So it's g, f, g. G of negative 1 of x. Yeah. G of negative 1 of x equals that. If you leave it like this, then you will have done everything right except reduce at the very end, so it's not a big deal. All right. Okay, number 9, find the inverse. Here we go. Rewrite it as a y equals. Okay, switch your variables. And then you are solving for y. Solve for y. So I'm going to add 7. So I get x plus 7 is equal to 5y squared. Right? Divide by 5. So y squared equals x plus 7 over 5. One more step. Now I have y squared, so we're going to take the square root. So y equals the square root of x plus 7 over 5. So that is your inverse. So instead of y, you can change this back, and this would be h of negative 1x. H of negative 1x equals that. Okay. Okay, number 10. Find the inverse. So change it to y equals. Swap your variables. Okay, now you're solving for y. So to get rid of the square root, I'm going to square both sides. So I get x squared. These cancel each other out. Okay, we're solving for y, so go ahead and divide by 13. So you get y equals x squared over 13. So f of negative 1 of x is x squared over 13. So that is the inverse. of this guy. I'm going to write it down before I erase it. Okay, number 11, nope. Oh, I have two number 11s. Ha! Okay, well, the first number 11 is you're given this, and you have to write the inverse. But I just want you to list the points. So you're just going to list the points. So when you're doing the inverse, you switch your x and your y values. So this becomes -2, -8. They just switch spots. Your y becomes your x becomes your y. This becomes -1, -5, 0, -2, 1, and okay, and 1, 1. That one stays the same because they're both 1s. So there you go. That is your inverse, your x and y values. So which? And then I'll go ahead and do the next number 11 while I have you. Absolute value cannot be negative. It cannot be negative. Absolute value is the distance from 0. Distance cannot be negative. Absolute value cannot be negative.